Okay, we'll start the session. I'll give you a quick overview on modularization techniques, which we discussed yesterday. So, what is the use of modularization?
To reuse.
So, we are going to create reusable modules instead of writing the complete code or complete functionality within the program. Okay, we break that program into multiple reusable modularization units so that you can reuse those modules in different programs. Okay, you can reuse those programs in different other programs so that you can reduce the duplicate code. Okay, you can reduce the duplicate code. You can improve the readability. You can easily understand the code. If you break it into different modules, it is easy to understand the functionality of the program instead of writing thousands of lines in the same program. And what is the other important advantage? Code maintenance is very easy. Code maintenance is very easy. If there is any common functionality in multiple programs, if there is any common functionality in multiple programs, you don't need to go and change each program if there is any change in the logic. If you are using modularization units, just change that logic in that particular modularization unit so that it will be automatically applied to all programs, whatever calling this particular logic. Okay, it is easy to maintain. Otherwise, you need to open all those hundreds of programs and change it. Okay, to update that particular logic or functionality. Okay, so what are the advantages? We can avoid duplicate code, easy to
Easy to
understand the
readable.
programs, that is better readability, easy to maintain the code, right? Easy to maintain the code, and we can reuse the code. You don't need to write same code again and again in many places. Okay. What are the different modularization techniques available? Subroutines, local to the program. Okay. So it's one type of modularization technique which is local to the program. Cannot call in other programs. Okay. Local to the program and cannot call in other programs. So subroutine follows procedural programming model, like it's based on functions. Okay, it's kind of function calls we do. It's not follows object-oriented programming model. That's why when you are writing object-oriented ABAP, right? So we cannot use subroutines inside the object-oriented ABAP. Okay, these are limited to procedural programming approach, procedural programming model. Okay, so how to call a subroutine? Using perform
Perform key. Subroutine name.
subroutine name and using
Changing.
and changing using our input parameters. If you want to pass any inputs for this subroutine logic, whatever the code you placed in between the subroutine, that will be executed, and they'll use these parameters. For example, p underscore input 1, p underscore input 2. Or if you want to pass some hard coded values, how can you pass? Within single quotes like this. Okay, you can pass any hard coded values. If you don't have any parameter or variable, you can pass the hard coded values like this within the single quotes as a input. Okay, it will also consider this value as a input. Okay, but without using parameters or variables. Always recommended to use some variable or constants, not the hard coded values. That's why don't use hard coded values. What about changing?
Display the
It won't display the output, it will return the output. Don't confuse between display and select, right? It is not to display the output, it is to return the output from subroutine. Okay, output will be returned to this particular changing parameter. See, whatever we are passing here, these can be parameters, variables, work area, or internal
internal
table.
table.
Okay, we can pass different types of data objects here. Also, we can return variable, work area, or internal table. Okay, and changing some parameter or any data object output value. Okay, now what is the subroutine definition? This is to call the subroutine, but what about the subroutine definition? What is the syntax for that?
Form, form and
Form,
end form. What is name?
name,
End form.
using. It will create input variables within the subroutine definition. By default, it will generate like p underscore and whatever the parameter we are passing here, it will generate like this p underscore p input one. It will generate automatically. It will add p at the beginning automatically. Okay, whatever the parameter you are passing here, right, in the subroutine calling, it will automatically add p underscore for the parameter name. Or you can also change this name. You can also change this and use your whatever the naming conventions you are following. You can change the name to that corresponding naming conventions and changing p underscore lv. I think it will generate c underscore. I think let's assume. Okay, this is changing parameter and end form. So within this form and end form, whatever the logic you want to execute, you need to write here by using these inputs and return the output to LV output. Okay, LV output equal to the specific functionality output. Okay, whatever the output we are returning, we need to return the output to this LV output. So it will return the value to this parameter, changing parameter. Now, what do we call the parameters which we are calling in the subroutine call, and what do we call the parameters which are generated inside the subroutine definition? Actual parameters, formal parameters. What are the actual parameters? These one. The parameters which we are passing in the subroutine call. These are the actual parameters which we are using in the programs, right? So parameters in the sense, don't go to the selection screen parameters. Okay, don't relate to the selection screen parameters. Parameters in the sense, whatever the inputs we are using in subroutine call. Okay, those parameters that can be an internal table, work area, variable. Okay, anything. We can also use like this LV input one, LV input two. So what do we call these parameters? Actual
Actual parameter.
parameters. Whatever the parameters we are calling in the subroutine call, the memory, the memory will be created for the actual parameters only. Okay, the memory in the program will be created to store the value, to hold the value for actual parameter only. What about these formal parameters? It won't contains any memory. It will just refer this memory location of this actual parameter. So these formal parameters, these are called formal parameters. What do we call the parameters which we are using in the subroutine definition?
Formal
Formal
parameters.
parameters. We call these as formal parameters. Formal parameters does not contains any memory. It will just refer the memory location of actual parameter, its corresponding actual parameter. Okay. So this p underscore input will refer LV input 1 memory location. It won't store any value. Only LV input will store the value because that is the actual parameter. And p underscore input, it is not going to store any value because it is a formal parameter inside the subroutine definition. Is everyone clear?
Sure.
So whatever the values we are passing here, these can be actual and this also actual parameter. Okay. And whatever the values we are using in subroutine definition, we call this as formal parameter. Okay. What about formal parameters? It will just refer that memory location. It won't actually hold any value. Okay. It won't create any memory. It will just refer to the actual parameter memory location. It's just by reference. Okay. It's just by reference. We call it as a pass by reference. We call that concept as pass by reference concept. We call this concept as a pass by reference. It will just refer the memory location of the actual parameters. The formal parameters always refer the memory location of the actual parameters. It won't create its own memory. Formal parameters are not going to create its own memory again. Okay. So what do we call that concept? Referring the memory location of the actual parameters. So here we are passing only memory address. Whatever the memory created for this actual parameter, we are just passing that memory location to this formal parameter. We are not creating any memory for this. Okay, that's why the actual value will be stored in LV output 1 only. But within the subroutine, this formal parameters will also contains the value, but it won't create any memory. It will just refer the memory location of the actual parameter. It won't create its own memory. Okay, so that if you update if you update any value of these parameters, right, within the subroutine definition, it will update in the actual parameters also. If you update any of these values, whatever the values you are passing in the, whatever the value you are using here, if you update any of these values here within the subroutine definition, right? So here you are passing 10, value 10 for this first input, and within the subroutine definition, you have changed this corresponding formal parameter value as 15. Now, automatically, the actual parameter value will also updated. Okay, that is pass by reference. So, what do we call this? Pass by reference. Okay, here we are just referring the memory location of the actual parameter. Is everyone clear? Okay, here we are just passing reference of the actual parameter, not okay. Now we are not creating any memory for this. Okay, so if there is any change in the value of the formal parameter, if there is any change in the value of the formal parameter, the actual parameter value will also be updated when we are using pass by reference. This is how we use pass by reference. Okay, this is the reference. This is the syntax for pass by reference. By default, it will create a subroutine with pass by reference. Okay, if you want, you can also specify the type of the parameter within the subroutine definition. Okay, here, and by default, it will create pass by reference. What is pass by value? We have another concept called pass by value. It is a very important interview question. I think it is asking since the last 15-20 years. The same question. Pass by value, difference between pass by value and pass by reference. Okay. Here what will happen in the pass by value? The formal parameters contains, right? The formal parameters contains own memory. Now what will happen? The actual parameters, for actual parameters, we are creating some memory and we are passing some value in the actual parameters. And again, we are creating memory for formal parameters also if we are using a pass by value concept. What we are doing here, we are creating separate memory for formal parameters also. Now, the memory will be created for actual parameter and formal parameter. Two places it's going to occupy the memory. Okay. For example, this actual parameter is the internal table with 10,000 records, and it will occupy. Let's take as example 1 MB memory space in the application server. If we use pass by reference, the actual parameters will occupy that 1 MB memory space, and formal parameters just refer that memory location, whatever created for the actual parameter. It won't create its own memory, right? But what about pass by value concept? If we use pass by value, right? If we use pass by value, it will create that 1 MB memory location for the actual parameter like internal table, and It will create a separate memory location for formal parameter also to hold those internal table records within the subroutine definition. It will create a separate memory location for formal parameters also. Now, how much space it will occupy in the application server? If you use pass by value concept, now what is the total space it will occupy in application server memory?
2 MB.
Total 2 MB. 1 MB for actual parameter and another 1 MB for formal parameter. Okay. So it is not recommended to use the pass by value concept because unnecessarily we are occupying memory in the system. When you execute the program, if you use pass by reference, it will take 1 MB. If you use pass by value concept within the program, it will occupy 2 MB, 2 MB memory space in the application server memory. All right, you are unnecessarily consuming system memory. Okay, so what is the pass by value syntax? It will create an own memory. One more important point: the value of the there is no change if there is any change in formal parameter within the subroutine definition. You updated the value of the formal parameter. It's not going to change the actual parameter value in case of pass by value, right? So pass by reference, it will always refers to the memory location of the actual parameter, right? And it won't create its own memory. If there is any change in the value of the formal parameter, it will update the same value to the actual parameter also. When you use a pass by reference concept, it always refers to the memory location of the actual parameter. The formal parameter always refers to the memory location of the actual parameters. It won't create its own memory. So it won't occupy unnecessary memory in the system. Okay. It won't occupy any unnecessary memory in the system. Okay. So pass by reference always. So pass by reference always the formal parameter will look for the memory location of the actual parameter. It won't create its own memory. Okay. If there is any change in the value of the formal parameter, the actual parameter value will be updated with the same value. If we are using pass by value concept, so formal parameter contains its own memory, right? If you update any value of the formal parameter within the subroutine definition, it's not going to update the value of the actual parameter of the subroutine. There is no change in the actual parameter. You can change the formal parameter locally, only locally within the subroutine because the formal parameter contains its own memory. It's not going to refer the memory location. If it is referring the memory location of the actual parameter, it will update the actual parameter also. But here, it's not referring. It will just transfer the value of the actual parameter to formal parameter into its own memory. Okay? Is everyone clear? And what is the syntax to define pass by value? What is the syntax to define pass by value? Let me show you here. When you are defining the subroutine, you use a syntax like value of within the brackets. You specify that formal parameter. Okay, you use a value. So when you define a formal parameter like this, then it consider it as a pass by value and it creates its own memory. And if you update the value within the subroutine, for example, p underscore input 1 equal to 20. It's not going to update this value 20 to the actual parameter, LV input. Okay. So it will update only that formal parameter. But if you are not using value here, this is passed by reference. Okay. This is passed by reference. Now you are updating the value of the formal parameter to 20, right? This LV input, this is the actual parameter, right? It will also update with the value 20. Okay. The value will be the actual parameter value will be updated automatically when you are using pass by reference, right? In pass by value, the value of the actual parameter is not going to be updated, but unnecessarily it will create a duplicate memory, right? To hold the same value. So when you are handling huge amount of data, for example, you are selecting some sales data, you might be select 1 million records from the database table, right? If you are passing that as value by pass by value, what will happen? Already you created one internal table and it occupies some memory in the system to store that huge amount of data, right? When you use pass by value concept in the subroutine and you are using that internal table in the subroutine call, what will happen? It will create one more memory location for the same internal table data to store as a formal parameter, right? Unnecessarily, you are occupying the system memory, right? It may impact the performance of the other programs, right? That's why I always recommended to use pass by reference until unless it is really necessary. If you want a flexibility to change the values within the subroutine and you don't want to update those values to the actual parameters, right? In that case, you go with the pass by value. But I don't see any necessary for that. Using pass by value, you can create a temporary internal table if you really want to have a flexibility to have a local copy of your data within the subroutine to do some operations. Okay, is everyone clear on actual parameter, formal parameter, pass by value, and pass by reference? Is everyone clear on this? What is the actual parameter? Let me create a simple subroutine. Yesterday I've already created, but let's see one more time. This is an old concept. Subroutine is an old concept, but if you need to work in the support projects, right, you need to be aware of this concept. Even in new S4 HANA systems also, we have a lot of subroutines in the standard programs. But if it is a custom program, no, no subroutines. Just we have other concepts, other modularization concepts we use. Initialization, I'm just adding the events for your reference. At selection screen for validation, start of selection, end of selection, top of page, end of page, and at line selection. Okay. Now I'll create a simple subroutine. So we obtain like there are two approaches, right? First, you create a subroutine definition and the call the definition in the program. Or first create the subroutine using perform uh, add numbers. Do we need to use using parameter? Is it mandatory?
No.
No, it is not mandatory. If you want to pass any inputs, then only we use using parameter. For example, I'll define two inputs here. Inline declarations are not going to work in subroutines. Okay, you have to define any variables or parameters explicitly. LV value 1 type I. I'll pass some default value 10 LV underscore value 2 type I value 20. Now we have two variables and I'll take one other variable for the output. LV underscore output type I. I'm not passing any default value. Now, so I'm using this subroutine to add two numbers. Otherwise, using parameter is optional. Here I am passing which parameters? Actual parameters or formal parameters? In the subroutine call,
Actual parameters.
we are calling here the actual parameters. We have created the memory for the actual parameters here. Okay, we have by defining the variables. Can we call it as parameters? Actual parameters. We are taking variables, right? These are variables, right? Whatever we define, and we are passing these variables in the subroutine call. Can we call this as parameters?
Yes, sir.
Yes. So parameter input parameters are different, and this actual parameters concept is different. Okay. And I am passing the actual parameters for input, and I want to return output into one more actual parameter using changing. The output will be returned to this actual parameter. Now let me create a subroutine definition. Manually you can create like this: form name using, sorry, form name using which parameters we need to use here?
Formal parameters.
Formal parameters. For example, I'll take like this: value 1. You can also take same name, no issue. Value 2 and changing one more formal parameter, LV, sorry, or in any name, you C underscore output. So it will always check by the position. The first parameter, the first actual parameter will refer to the the first formal parameter will refer to the memory location of first actual parameter. The second formal parameter will always check for the memory location of the second actual parameter. It always check by the position. Okay, it won't consider by values. So that's why the position is important. Okay, and this formal parameter will refer to this one, end form. Okay, now I'll do some C underscore output equal to, is it passed by value or passed by reference? What is this concept? We are just referring the memory location of the actual parameters. We are not creating separate memory this for this formal parameters. This is which concept? Passed by
Pass by
reference.
As by reference.
Here we have only one memory for the value. We are not creating separate memory for the formal parameters. Okay. This is how you can create the subroutine definition at
Yeah.
the end of the program, because after the executable state, you should use form and end form only after the executable statements. I'll try to print some output, LV output, right? Let me change value of the any of these parameters, formal parameters, p underscore value 1 equal to 40. Okay. So here we are updating the formal parameter with a new value. Here, what is the value we are passing for this formal parameter? 10. But here within the subroutine, we have updated it to 40. Now let's check whether it will update the formal parameter or not. Sorry, it's not end of
Name.
program, end of selection. Pretty printer.
Add member cell. Any formal information name.
Okay.
Add
The name of the subroutine is not correct. So here we are updating the value of the formal parameter. That's right, the formal parameter. Now, if you update the value of the formal parameter, what is the expectation? It should also update the value of the actual parameter. It won't update that value locally. It will update the memory location of the actual parameter also. Okay, that's why there is some warning display. So do not change the formal parameter so that it will update the value of the actual parameter. When we go for pass by value, when you need to use these formal parameters values locally and you want to have some calculations or do modifications on that formal parameter, then we need to use pass by value because it's not going to affect the value of the actual parameters. Okay, let me debug the code. You can observe the difference. What will happen if you press F5? It will go inside to this subroutine because it is step-by-step execution. F5 is a step-by-step execution. What will happen if you press F6? It will complete the subroutine execution in a single step. It won't go inside the subroutine code. It will complete the execution in a single step. If you press F6, you press, right? What is F7? I'm pressing F5. Now I've entered into the subroutine, but I don't want to debug further. I want to return to the subroutine call. What I need to press?
F7.
F7. If you
7.
press F7, it will terminate this and it will return back to the program logic. Okay. Now check here. Let's check the parameters. These three are the what type of parameters? Actual or formal?
Actual.
These three are the actual parameters, and these three are formal parameters.
All
At present,
parameters.
the value of the actual parameters and formal parameters are same, but within the subroutine, I'm updating the value of the formal parameter. I've updated the formal parameter. What about the actual parameter? The value of the actual parameters also
Parameters.
updated. It is
Changing.
changed. Okay. And when I change the C output formal parameter, it is automatically updated the value of the actual parameter LV output. Okay. Clear? So the formal parameters values are updating the value of the actual parameters in case of pass by reference. Now let me change it to value. You can also use the specific data type here. Type. You can also define the type here. Type I. Like by like this. You can also define like this. Okay. Now, how can I make it as pass by value?
Adding value.
Adding value in the subroutine definition. Value within the brackets. I keep that formal parameter. Okay. Now let's see how it will behave. I'm not changing anything. So I press F6, what will happen? It will complete the entire subroutine logic in a single step. It won't go inside the subroutine and debug line by line. Okay. So press F5 just to observe our scenario. Pass by, sorry, actual parameters. These are the formal parameters. At present, both values are same. Now press F5. I am updating the formal parameter here with a new value, that is 40. This one. F5. Formal parameter is updated. Is there any change in the actual parameter?
No.
No, sir.
No, there is no change in the actual parameter because we are using pass by value concept. It contains its own memory location, right? It will update that value in the own memory. It's not going to update the value of the actual parameter. It will update the value of its own memory. Okay? Is everyone clear? So there is no change in the formal parameter when you use pass by value concept. Okay? So what do you need to understand? You need to understand the actual parameter. You need to know what is formal parameter. You need to know what is the pass by value and pass by reference. Okay? Pass by reference means we are just providing the memory location, right, of that actual parameter. Okay? We are not creating any separate memory for the formal parameter. The formal parameter always points to the actual parameter memory location. But in case of pass by value, the formal parameter creates its own memory and it will always point to its own memory, not the formal parameter memory. Okay, clear? Is everyone clear on this?
Yes, sir.
So subroutines are local to the same program. You cannot call subroutines in a different program. These are local to the same program. You can pass the inputs by using parameter and return the output by changing parameter. Okay, not only variables, you can also pass work area data, internal table data as input to the subroutines. Okay, so the same subroutine can be called multiple times within the same program. Okay, the same perform can be called multiple times with different values. Okay, you can call with the different values. Only the position is important. Whatever the position you are using in the actual parameter, same position you have to maintain here. Okay, you don't need to create manually. Let me comment this. You can also generate the subroutine automatically. How to generate it? Double click on the subroutine name. Save it. Double click on the subroutine name. So it will create a subroutine definition. For now, just select master program. It will add that subroutine definition at the end of the program automatically. So by default, it created pass by reference, not pass by value. Okay. If you want to make it pass by value, use a value syntax. Okay. Is everyone clear?
Yes, sir.
like this. Okay. This is pass by value. You are adding value to the formal parameter. Okay. Right. Right. You can also change this auto-generated parameter names. When you are using pass by reference and trying to update the value, when you are using pass by reference and when you are trying to change the value of this formal parameter, it is displaying a warning. Do not modify using reference parameter. Instead, define the parameter using value. Define the parameter using value because you are going to update the actual parameter value also if you change any value in the formal parameter. Okay, is everyone clear on this? So the next concept is include programs. So I think I'll start it tomorrow since we have introduced this formal and pass by reference, pass by value concept. It took some time. Okay, everyone practice these concepts. From the next session onwards, we'll continue with include programs and function modules. These are also
Sir,
modularization
please
techniques.
give the server details.
Any questions?